Hello everyone, welcome back to Michael's here. In today's video we are going to discuss something very important about flood prediction, flood mapping, and then flood detection. So I've been receiving a lot of comments from people that they want to download data from especially Google flood app, but it's not possible for them to download. So today I'll show you why and then where you can download those data or where you can model those data. So welcome once again, and then if you're here, please don't forget to subscribe, share, and like. So a lot of people has discovered Google flood app, and then they think they can download flood data directly, but when they try, nothing works. So in this video I will show you what Google flood app actually does, why you cannot download daily flood data from it, and then the best alternative method to use, that is the Google Earth engine. So first of all, Google flood app is an online platform developed to provide a near real-time flood forecast and monitoring. So we have satellite data, the hydrological data, and then machine learning techniques, and then add AI too. We can use AI to predict data there, which it allow for view flood prone areas, check flood forecast, and then the others. So many users ask, can I download daily flood data from Google flood app? The answer is no. You cannot download data directly from this platform that you see here. So here you cannot download any data from here, but you can view flood data, as you can see, as I'm viewing flood data here. And then you can do visualization, decision making, and then disaster awareness. So if you want to identify flood prone areas and then how flood are affecting any other area, you can use this one. So let's quickly get into it. So this is our Google flood app, where you can see we have our river flooding here, we have extreme danger warning, no data, and then the normal here. So you see all these points here are the normal flood area, so we don't have any danger or extreme flood area here, as you can see here. And then here too, if you look at here, you can see we have the likely and then the highly likely. So we only have the likely, we don't have the highly likely here. And then also here you may see we have extended coverage. So all these points that you see here, if you check the extended coverage, you see a lot of points will be added here. And then if you click on any point, you may identify the area that the points cover, and then how those places are affected by flooding. So we are going to view some of them, but before that, let's continue. So here we have the inundation probability to predict how flooding are occurring or how flood are affecting. Then we have inundation history, which we have the worst 5% of time, the worst 1%, the worst 0.5%. So how the flood history are affecting. So let's quickly get into it. So let's uncheck this one and then click on this one, and let's see. Alright, so this one you may see here where these points cover. So this point that I click on it cover this area, which extends from Ghana to Burkina Faso. You can see it cover this area here, from here to there. And then if you come to the left side here, you can see the white water. So that's the white water forecast. So this is the flood forecast for white water, which you can see we have the warning here, we have the danger here, and then we have the extreme here. And then here you can see the discharge in meter cubed per second, which you can see it here. And then if you come here, you have the gauge information, the high confidence gauge, and then the others, and then the area that the basin cover, which is this value in kilometer square here. And then so that is all for Google flood app. Here you can view data, you can do forecasting, but here you cannot download data directly as a GeoTIFF or as a shape-file. So you can only view data from here. So let me show you the quickest way that you can do flood mapping or flood prediction using the Google Earth engine. Mostly using the SAR, that's the synthetic aperture radar, in Google Earth engine, using the Sentinel-2. sorry, the Sentinel-1, sorry, using the Sentinel-1. So let's quickly get into it. So you need to get your coding right. So here is my project here. So here you can see have my coding here, which I will leave my the code on the description of this video. So if you want to use the code, what you just need to is to change my study area to your study area, and then you run it. And then if you want to change the duration, and then Sentinel start from 2015 to current. So if you want to change the dates, you can change the dates. But if you want back from 2015, let's say 2010 or to 2000, there you have to use different data sets. So here we are using Copernicus here, so that's the Sentinel. So here you see we have our dates here. So we have 2023, 04, 05, and 06 here. So and then this is our study area here, and then if you come here, this is the data set that we are using. So that's the Copernicus X1 graded data here, which you can see here. And then we have our transmitter receiver polarization, that's the VV here. And then we have our clip. So this clip means that we are clipping the image to our study area. That's what is showing here. So here we have clipped the image to our study area. So this is my study area here. So I have clipped the image to my study area. That's why you can see that the image cover only my study area here. And then we have other variables. We have here is where we have the flood detection here. So here you are going to see we have the JRC global surface water here. So it's also a data set that we use to do flood mapping here. And then we have the slope mask. So before you do flood map, you need to mask your slope here. And then we have here is our cleaning. So you see Sentinel image need further processing before you can use it. So and then here's our flood area. So here we are just determining the flood area, and then we have our histogram here, which I will explain the histogram to you. And then we have our export code here. So this is the simplest way to calculate for flooding using a Sentinel-1 image here. That's the synthetic aperture radar. And then here you can see we have our flood area here. That's the 7.60 kilometer squared. And then here our legend will show you after image and then before image, and then the threshold is here, and then we have a flood area of 7.61%. So here we have our histogram, as I was talking about here. So here this is our histogram here. So Sentinel-1, that is the radar, use a bus cutter. So the bus cutter is how the sensor or the radiation that the sensor capture on it, and the earth surface reflect back to the sensor. So here we have the scatter. So on water body, the bus cutter is very low, which means that when the sensor sense anything on the water body, the amount of energy that sent back to the sensor is very low as compared to the normal surface of the earth, which has so that's how the radar is able to identify a water body and then a different class. So if you compare water body and let's say a built up area or a bare area, the energy that is sent back to the sensor is low in where we have water body, and then it's high in where we have the bare land or a developed area. So this is our bus cutter here. You can see we have our values from 2000 to 14,000 here, and then you see how the values are. So here is the negative values here, and then here is our positive value here. So you can see the variation in the plot. So this is a simplest way. So let me show you where we have our flooding here. So here you can see we have our flooding here. So here we have where we have the blues. So that's where we have where flood has been occurred here. So here you can see we have our flooding here, and then if you come to the legend, we have before flooding and after flooding. So we have before flooding. So here you can see we have our flood areas here, and then we have before flooding, and then we have after flooding here, and then this is the flood. So if I remove the flood, you see the blue portion has been removed, so that's the flat area. If I check on it, you can see we have the flat area there. So thank you very much for your attention, and then please, this is a simplest way to calculate for flat mapping, but this is not limited. There is a lot that you need to do, but this is the simplest way that you can identify flat area in a particular study area. So thank you very much for your comments, and then I really appreciate your comment. And then please, if you have any question, if you have any concern, don't forget to leave it on our comment section. Thank you very much for your attention.